helping to moderate, and this presentation will be given by Kerri Spooner from the Auckland University of Technology on designing differential equation courses through modeling activities.
Okay. Okay, thank you very much for the introduction and welcome everybody this evening. I think it's evening for most of you guys. For me here, I'm in New Zealand and it's 1 o'clock in the afternoon on a Saturday. So there we go. So I'm Dr. Kerri Spooner and I'm at AUT University in Auckland, New Zealand, which is about right here is on the map. There is Auckland right there. So, and this evening, this afternoon, I'm going to talk to you around designing differential equations courses through mathematical modeling activities. So, oh, what's happening here? My thing's not sliding. Whoops,
Mm.
it's not moving. Okay, aha, there we go. Right. So just a brief outline uh, for for this talk is I'll start off with my motivation and background for the talk. Then I'm going to share with you three different modeling activities that can be modeled using differential equations that we've come across in our tertiary mathematical modeling courses here in New Zealand. And then I'm going to propose a potential sequencing framework for using these activities. But just to sort of ground us and everything in ground us, first of all, I just want to pose the question, like, why do students typically leave differential equations courses able to solve differential equations but unsure of their application? Now, I'm not 100% sure what's happening in other parts of the world. I hear sort of two different stories, particularly in the States, about about whether differential equations are being taught in context or not in context. But for us in New Zealand, that there's a sort of still quite a traditional mindset where generally the student experience of a differential equations course are frequently abstract, where they're taught without any connections to any meaningful applications, and they can be quite technically demanding. We also know that there's been research done that if a student is taking an applied maths course and their mathematics course where they've learnt about differential equations is taught with the differential equations in abstract form, i.e., devoid of context, that when they come to actually using them in their applied maths course or their physics course, that they tend to not draw on the differential equations. As such, they tend to draw on other tools opposed to using the differential equations because of that initial experience about them being taught abstractly. And sorry, I should reframe that. When I'm talking about the applied maths, I'm talking more about like your physics courses, some of your engineering courses. So when they're coming across them as a useful tool in those courses, they're not necessarily picking them up because they've already had this experience that they're abstract. They're abstract. They use them in abstract situations. And I know that I'm already talking to the converted here, got already, and I can imagine some of you already can see one of the solutions as mathematical modeling. And I mean, by its very nature, we know that modeling is about connecting real world context to mathematical equations, and in our case, differential equations. By being able to make those connections and explore them in a real world, in a contextual situation, the students are enabled to develop a deeper understanding of what the differential equation means, as well as some deeper conceptual understanding, as well as them having an opportunity to explore all of those modeling behaviors, that investigation, that research skills, that collaboration, that critical thinking, that creative thinking, and thus providing a really strong opportunity for learning real world differential equations. And so, background. In 2003, me and a colleague were approached to develop a new, what we call second year undergraduate course here in New Zealand about modeling and differential equations, not just the differential equations and not the modeling, the two of them combined. So, for me, this was really about an opportunity to start giving mathematical modeling just as much focus as the differential equations components of our traditional traditional maths courses. And I'd also had prior research experience with looking at different mathematical modelling activities used across some of our tertiary modelling courses here in New Zealand. And in particular, I'm going to talk about these three today. I'm going to talk about when using popular fiction to using that as an opportunity for students to model. I'm also going to talk about using already developed models that have been published in the form, and we call them case studies, and using them for students to have an experience of getting to know a model as well as an opportunity to participate in modifying that model. And also then the open-ended activities, which are just generally normally one statement, one open-ended question, which is really, really ill-defined, and then students go and embrace that from beginning to end. And just before we start talking about these in any detail, just want to also say that all of these activities all happen within a group setting and a collaborative environment as well too. So just real quickly, before we get into things, just all of these three different activities, so I'm going to present them today, have a different level of, students have a different level of responsibility for the modelling process. So for your case studies, that is where they have the least amount of responsibility for the modelling process. For your popular culture, now you're starting to increase the level of responsibility for the modelling process. In this particular situation with popular culture, generally what happens is you've chosen a context, and I'm going to talk today about using zombie modeling scenarios, zombie movies as modeling scenarios. So you already have your context, and we normally teach the base model, and in this case the SIR model, to the students, and then we let them loose on having a modeling these particular type of activities. So therefore the responsibility sort of happens on developing and modifying a model for the particular zombie movie scenario. And then you have the completely open-ended activities, and an example of that would be how high can I jump from a building without causing injury? And there the students have, or the student groups have complete all responsibility of all modeling decisions, right from background context, choosing the base model, developing the model, testing the model, etc., etc. So here we go. Let's start with popular fiction. And as you can see, zombie models here, zombies are all here. And just a little reference down here, if anybody want to look any further into detail with using zombie models as a popular fiction for modeling. We know that Lufgren and Co have done some work in that space. Okay, so characteristics of a popular mod fiction modeling activity. For me, I'm starting with this one because I think they're a really good entry point for students being able to experience the modeling process. And a characteristic, just picking a popular fictional scenario could be what's the most late a movie that's out at the moment that everybody's interested in. And obviously by picking something that's popular, you're also picking something that majority of students should have be familiar with the context. And again, like I've already mentioned, yeah, teach the students the base model beforehand. And then obviously they now have the responsibility for everything past that point. And so they're still getting that opportunity to be engaging in collaborative group work as they explore different possible approaches and decision making within their groups. And so, like I've been hearing at all the teaching talks I've been going to today, again, we know that this modeling with differential equations enables students to have a real active learning experience. And then in the way that we like to think about approaching them, a collaborative, active learning experience. And for me, I suppose that's quite important, the collaborative component, because for me, it's quite important to be teaching modeling in a way that mimics what actually happens when you're out in the real world, you're in a job and you're undertaking modeling projects, and that always happens within a team or within a group. Another element of this particular activity too is when the students have all had a go at creating their models for their particular movies, a zombie scenario, is that you always get them to present their presentations to the class so that there's opportunity for peer-on-peer learning as well. They can share what they've got and engage with the students there. So here we go, pros. Because it's fictional, it creates a situation where that generally it's a modeling in a no pressure situation, not a real situation. So we're not looking at something that's going to, make sense in the real world. And so we find students like quite willing to experiment and engage. The focus of the modeling is shifting to the structure of the equation and how to build the model, opposed to deciding the base model. So we're hoping that that's going to reduce some of the cognitive load as well. And of course, because it's a popular context about around popular fiction, you're removing some of those obstacles with the context specific knowledge. And again, like I've already said, an opportunity for some good collaborative active learning. Um, and normally this can be just conducted in like one session, in like a lecture session or in a tutorial. Um, and so it's can be quite easy then to find a place where you could fit it into and add it into your course schedule. And so for me, they are really good introduction to the modeling process, while reducing any pressure to perform. Okay, now the cons, are not really cons, I suppose. These are really solutions to cons. Is for this to be successful, I think that you need to be able to teach. You have to obviously teach the modeling cycle beforehand, and then also teach the students the base model and have them playing around with it so they've learnt the mathematics and and help them with some possibilities of how you can modify the base model. And in this particular situation, it was using the SIR model. Um, Now, what we did see from the research that I conducted with these activities, that if students had missed those lectures, particularly around the mathematics of the model, that they sort of felt sort of all at sea when they got into their group. So those particular students could potentially have some fragile conceptual ownership over the learning that can come out of these activities. But in saying that, in 2024, I took this particular activity to the IGME conference, International Maths Education Conference, when it was being hosted in Sydney. So we did it with a group of adults, all with varying ranges of maths, some down to like quite limited maths, all the way to being quite expert. And we found that when it's set up properly, everybody can participate. And it was really exciting to see. Um, Now, the next activity I'm going to be moving to is when we use case studies for modeling. And in particular, in this situation, we're using models that have been already developed and published in research. And in particular, we were drawing from some case studies that have been published in the book by Barnes and Fulford. And here we go. That one example is like, how hot is it going to get in the attic? Another one was about how to control a possum population with vaccination. And for us in New Zealand, the possums have been a bit of an issue, particularly around our native bush and forests. And then another example of a case study that has been used is where we have the control of the prickly pear cactus when it was introduced to Australia by introducing a moth, an Argentinian moth that liked to eat the prickly pear fruit. So there we go. So characteristics of the case study modeling activities. For me, these make up a really good backbone of the course because they give students an opportunity to learn about the model and then experience the modeling process to identifying a limitation of these models and working through a modification um, for those limitations. So they have already developed, a case study has an already developed model addressing a specific question or questions. They give the opportunity to be able to collaboratively, both independently and in student groups, to be able to explore and get to know a particular model, and then have the opportunity to model and extend that model in order to experience the modeling process. So, because we're already dealing with an already developed model, these students have partial responsibility for the process. Um, there is a need again to make sure that you've taught the modeling process explicitly beforehand, which is actually the case in all of the activities that I'm sharing with you this evening, this afternoon. But if you, but we have seen when they have been just introduced as a case study that they can, without too much emphasis on the modeling process, that instead the students are just getting that an implicit exposure to the through engaging with the case study opposed to any explicit exposure. And again, um, a collaborative, active learning environment, and again with student presentations. So again, and the student presentations for these, again, we normally do them in three key parts, three key presentations. The first presentation, students present the model and what each of the terms of the model mean. Second presentation, they present the mathematics and even any visuals, any phase portraits, or time versus behavior graphs from the models. And then the third presentation is about identifying the limitations and making a modification and working that modification through. Now I'm going to keep going because I'm conscious of time as well. Pros, opportunity to learn about models before attempting modeling. And so getting an opportunity to introduce rich modeling ideas without initially overwhelming students with the modeling process. Um, they still get to experience the modeling and process through modifying and extending. And because of this, there's a gradual transfer of responsibility of the modeling process to the students. And again, collaborative, active learning space. Cons, okay. Again, these are solutions to the cons. Again, make sure you're teaching them a really explicit modeling process. The students have that as a scaffold for when they get to the modifying the case model stage. Um, some key assumptions may be hidden. There is a risk we saw of this of students focusing on the model outcomes and the mathematics of the modeling rather than the modeling process. But again, the solution to that is making sure the modeling process is explicit for the students and in front of them. And we also saw that like there's class time, allocate class time to these, but students also need to be working independently on this themselves and also meeting in groups outside of class, so that they can really make progress with this. Okay, and I'll skip through that. So the last activity I'm going to look at is the open-ended modeling activity. And here we go. Here's an example of one that you could use is how high can you jump from a building without causing injury? As you can see, it's ill-defined. The model to be developed for a novice student is not immediately obvious. So students get to experience the full modeling process here. And by doing that, they get an opportunity within their groups to actually be able to discover and take ownership of their own modeling process. Does have quite a high cognitive demand, but of course that is navigated within, within the fact that we're working within student groups, so they have each other as resources. And again, collaborative, active learning experience. And it's really suitable for an end of semester project. So pros, holistic modeling experience. I'm going to whip through these because I'm conscious of time. You obviously a chance to be creative in this modeling space, just like with the popular fiction activity, a chance to experience an authentic real world modeling process and discover it really for themselves. Collaborative and discussion. For me, the biggest thing is about giving students ownership of the modeling process. And there's opportunities for productive struggle, learning through productive struggle, and reflect scientific and engineering practice. So, cons, there is a risk of, cognitive overload. Where do I start? But again, you have the groups and you provide the modeling cycle as a modeling scaffold. Okay. And you can work that through into like if you're wanting them to write up a report, work it through, write the report, say, talk about this stage of the modeling stage, this, the next stage, etc. So that can really, really guide the students. These are time intensive. You could either run them over a course of a couple of, different of 2 weeks, or you could 2 or 3 weeks, or you could put aside a day, a whole day, and get the students to come in for a whole day. But that generally happens on, I mean, when I've seen this done like that, it's normally happened on a Saturday or a public holiday. Um, Not ideal for early in a course. So you're wanting to schedule this as your sort of last activity of your course to bring and synthesize everything together and not too big of an assessment weighting because you want to be able to have students to have that freedom to feel like they can actually explore and really play around with it. So here we go, my last slide for you guys. So putting it all together, this is my proposal of a potential sequencing framework. For me personally, in about week 3 or 4, I've introduced a modeling process. We've done a little bit of the modeling. I've introduced the SI model and played around with some of the modifications, like putting in your logistic components and your carrying capacity. Oh, sorry, my tongue's getting tired. Carrying capacity. But they're a really good way because they're fictional of students just getting in there and playing around and building their confidence and seeing that modeling is creative. Then use those case studies as a backbone of your course so that like students can get to know the models and then experience modeling through modifying them and then finish off end of semester project as an open-ended task. So, but I suppose the key thing again for me is that there's no single one best modeling activity, and the value really lies in your combination and your sequencing. Just some quick teaching strategies that I might implement is sort of to underpin everything, make sure everything works. And I will go quickly, I'll flick there. And if anybody wants to know any more about the particular 3 activities that I've talked about, I do have a publication where it goes into a lot more detail and connects them really strongly with the differential equations there. So that is me. So, hey, Ben.